Primary School Math Olympiad Geometric Challenge 23. Quadrilaterals. This is a challenge for Primary School Math Olympiad for questions related to geometry for quadrilaterals. There are 5 questions. The challenge is to complete them within 25 minutes. If you can't achieve it the first time, do not be disheartened. With practice, if one works hard and revise this challenge multiple times, one should be able to complete this challenge within 25 minutes. Question 1. A parallelogram is folded along the 2 farthest corners. The ratio of total area after the folding versus the original parallelogram area is 7:9. The overlapping area formed the shaded area, which is 18 centimeters squared. What is the area of the original parallelogram? Question 2. The diagram comprises rectangles A, B, C, D and square PCQR. BC is 8 centimeters, QC is 12 centimeters. Find the value of AB. Question 3. The diagram comprises a big rectangle which are divided into 4 smaller rectangles with their areas shown on the diagram respectively. Find the area of the shaded region. Question 4. A rectangle with length to width ratio of 3:2. The length is increased by 9 centimeters and width by 16 centimeters to form a new rectangle. The new rectangle length to width ratio is 4:3. Find the original rectangle length and width. Question 5. A rectangle with length to width ratio of 3:1. The length is decreased 10 centimeters and width increased by 15 centimeters to form a new rectangle. The area of the new rectangle increased by 25 centimeters squared compared to the original rectangle. Find the original rectangle length and width. Answer for question 1. Assume A is the area of the original parallelogram. The ratio of total area after folding versus original parallelogram is 7:9. As such, the folding lost 2/9 of the parallelogram area, which is equal to the overlapping areas or shaded area. Given 2/9 of A equals 18 centimeters square, thus A equals 81 centimeters squared. Answer for question 2. The area of the red dotted lines triangle PCD is half of the area of ABCD and also PCQR respectively. As such, half of AB times 8 equals half of 12 times 12. Work out the equation. The answer is AB equals 18 centimeters. Answer for question 3. First, find the area of triangle A. Redivide the upper 2 rectangles using the same ratio of lower 2 rectangles, with ratio of 24:36, which is 2:3. The total area of the upper 2 rectangles equals 10 plus 30 equals 40. Divide 40 into a ratio of 2:3, which is 16:24. A equals 12 centimeters square, thus the shaded area in the upper 2 rectangles equals 15 minus 12 equals 3 centimeters squared. Redivide the lower 2 rectangles using the same ratio of the upper 2 rectangles with ratio of 10:30, which is 1:3. The total area of lower 2 rectangles equals 24 plus 36 equals 60. Divide 60 into a ratio 1:3, which is 15:45. The shaded region in the lower 2 rectangles equals 45 minus 36, then divided by 2, which give a result of 4.5 centimeters squared. The total area of the shaded region equals 3 plus 4.5 equals 7.5 centimeters squared. Answer for question 4. Assume the length and width of the original rectangle is 3A and 2A respectively. 2A plus 16 is the length of a new rectangle. 3A plus 9 is the width of a new rectangle. The length over width of the new rectangle is 4/3. Work out the equation. You have A equals 2. The original rectangle length equals 3A equals 6 centimeters. The original rectangle width equals 2A equals 4 centimeters. Answer for question 5. Assume the length and width of original rectangle is 3A and 1A respectively. Area of the new rectangle minus area of original rectangle equals 25. Area of the new rectangle is the result of 1A plus 15 times the result of 3A minus 10. Area of original rectangle is 1A times 3A. Work out the equation. You have A equals 5. The original rectangle length equals 3A equals 15 centimeters. The original rectangle width equals 1A equals 5 centimeters. Thank you for watching. Please like and subscribe.